In this video, we will calculate Reynolds number for water at 20 degrees Celsius flowing in a 2-inch Schedule 40 pipe at 20 gallons per minute. We want to know what type of flow is it, laminar, turbulent, or transition. So we're solving for two things. We're solving for Reynolds number, and we're also solving for what type of flow. And as a note, the density of water at 20 degrees Celsius is this number right here. And a 2-inch Schedule 40 pipe, the inner diameter is 2.067 inches. And lastly, viscosity of water at 20 degrees Celsius is equal to 1.005 centipose. So Reynolds number is equal to D, which is the length of the flow, times the flow velocity times density divided by viscosity. And a good idea is to convert everything to the same similar units because Reynolds number is unitless. And so we can say that D is equal to 2.067 inches because we have a 2-inch Schedule 40 pipe, and so the inner diameter is 2.067 inches. We know that 12 inches is 1 feet. And so we would get 0.172 feet. Next, we will determine flow velocity. So the flow velocity is equal to the flow rate divided by the flow area. So Q stands for the flow rate, A is the flow area. And so A for a pipe will be pi times D divided by 2 squared. So we would get pi times, the D was 0.172 feet divided by 2 squared, and we would get 0.0233 feet squared. So we are given that it's 20 gallons per minute. That is the flow rate. So Q is equal to 20 gallons per minute. And again, because Reynolds number is unitless, a good idea is to convert to a same unit. So we have feet here, so I should convert gallons into feet cubed. So we know that 7.481 gallon is 1 feet cubed. I will also convert minutes to seconds. 1 minute is 60 seconds. And so I would get 0.0446 feet cubed divided by seconds. And so now I can calculate the flow velocity. So flow velocity is equal to Q divided by A. Q was 0.0446 feet cubed divided by seconds. Now divided by A. A was this number right here. So 0.0233 feet squared. And we would get 1.912 feet divided by seconds. So right now we know D, and we also know the flow velocity. Next, we will calculate density. So density is equal to, so it says density of water at 20 degrees Celsius is 998.23 kilograms divided by meters cubed. And so we want similar units, so we should convert kilograms into pound mass and meter cubed into feet cubed. So 998.23 kilograms divided by meter cubed. We know that 1 kilogram is equal to 2.205 pound mass. And now we need to convert meter cubed into feet cubed. So we know that 1 meter cubed is equal to 100 centimeter cubed. And we know that 2.54 centimeter cubed is equal to 1 inches cubed. We also know that 12 inches cubed is equal to 1 feet cubed. And this right here would give us 62.3 pound mass divided by feet cubed. So now we know almost everything. Next, we just need to convert viscosity into better units. So we're given that viscosity is 1.005 centipose, and we should convert to something like this: pound mass divided by feet times seconds, because we have D as feet, and we also have pound mass for our density. So that would be a good idea. And so viscosity is equal to 1.005 centipose, and we know that 1 centipose is equal to 6.72 times 10 raised to negative 4 pound mass divided by feet times seconds. And we would get 6.75 times 10 raised to negative 4 pound mass divided by feet times seconds. So a recap, Reynolds number is equal to this formula right here. We know that D is equal to 0.172 feet, V is equal to 1.912 feet divided by seconds, density is equal to 62.3 pound mass divided by feet cubed. Finally, viscosity is equal to 6.75 times 10 raised to negative 4 pound mass divided by feet times seconds. And now we will use the formula. So Reynolds number is equal to D times V times density divided by viscosity. We said that D was 0.172 feet. V we said was 1.912 feet divided by seconds. And density we said was 62.3 pound mass divided by feet cubed. Now this whole thing will be divided by viscosity. Viscosity was 6.75 times 10 raised to negative 4 pound mass divided by feet times seconds. Now just multiplying everything out and dividing, we would get RE, Reynolds number, is equal to 3.035 times 10 raised to 4. Now we need to check our units because Reynolds number should be dimensionless. And if it's not dimensionless, we must have did something wrong or we need to do further conversions. So let's check. Feet times feet would give us feet squared. Now this is being divided by, so it goes to the numerator. So we have feet cubed in the numerator. We have pound mass. So we have times pound mass times, this is being divided by, so it's going to go to the numerator, so seconds. Now this whole thing will be divided by seconds, feet cubed, seconds, feet cubed, times pound mass. We're dividing by pound mass. And so now let's check. Feet cubed cancels, seconds cancel, pound mass cancel. And so it is dimensionless. So Reynolds number is equal to this number. So this is one answer that we're looking for. We also want to know if it's going to be turbulent, laminar, or transition. So this number right here is about 30,000. And 30,000 is greater than 4,000. And since it's greater than 4,000, it's turbulent. As a side note, if Reynolds number is less than 2100, it's laminar. If it's greater than 4,000, it's turbulent. And if it's in between, it's going to be called transition. And that's all we need to do for this problem.